RAID is a redundant array of independent disks or drives. And basically what it means is that you take a bunch of drives and put them together and you end up with a larger pool of storage. Now the cool thing about RAID is that it doesn't just pull things together like LVM and give you a bunch of data. It allows you to do some pretty neat things with performance or redundancy. So I want to talk about the different RAID levels that we can offer using RAID, specifically Linux RAID. Linux has a software version of RAID which is very powerful, very robust, and surprisingly efficient. So basically, I want to make sure we cover all the different RAID types. And to do that, I want to show you this big scary dragon. Now, here's the idea. I'm gonna talk about RAID, but instead of a redundant array of independent drives, we're going to say they're a redundant array of independent Knights of the Round Table, okay? And in true 80s fashion, our knights are going to be just squares like from Atari's Adventure. Anyway, here's the deal. With RAID 0, our drives are set up in a stripe, which means that they work together. Reads and writes happen across two drives very, very quickly. And so with RAID 0 or a striped array, it's very fast, right? You can get dual writes and dual reads at the same time. The problem is, let's say that the knights are attacking the dragon and the dragon is attacking the knights. If we lose one of the knights, well, then the dragon can get right through to the king. Because if you lose a single drive in a striped array or in a RAID 0, all of a sudden your data is gone because half of your data is written on that other drive. So while it's very fast, they better kill the dragon quick, because if one of them fails, all of their data is gone and the king gets destroyed. Now, RAID 1 is kind of the opposite. It still has multiple drives, but they're set up in a mirror, which means every time you write something to the first drive, you write it to the second drive. So you have a complete copy of both. Now, because they're in a line like this, they can only attack the dragon one at a time, right? They can't both attack the dragon like over here in the striped setup. But the advantage here is if one of them dies, there's still another full knight there protecting the king. Same thing with your data, right? If one of these dies, you still have a full set of your data because you've been writing it to two drives the entire time. So a mirror doesn't give you any speed increase because you're not spreading the writes across here. You're actually writing all of your data two times, once to each drive. So you don't get any advantage over a single drive when it comes to speed, but you do get that advantage of either drive can die and you still have full protection for your data. Now, RAID 5, this is a little bit different. RAID 5 uses a parity disk, and how that actually works is like some digital magic that is beyond the scope of this nugget, and to be quite honest, it still stumps me a little bit. But conceptually, how it works is you have multiple drives, 3 minimum, and any of these drives can die. Any one of them, it doesn't matter which one, and all of your data is still in place. So you get the advantage of being able to lose any drive in your array. The disadvantage is you lose one drive's worth of storage. Now, what do I mean by that? Let's say these are all 5 gigabyte drives, okay? If these are all 5 gigabyte drives, together that would be 15 gigabytes. But you lose one drive's worth of storage for that parity magic. And so if you have 3 5 gigabyte drives, you're only going to have 10 gigabytes of usable space. But the advantage is it's writing to multiple drives as it's going along. And if one of the drives dies, you still have all of your data represented in the remaining drives. Now, if you lose 2, of course, then your data is corrupt and you're done. But you can lose any drive. And it's not just like this is the drive you can lose. No, you can lose any one of these and all of your data is still there. It really is magical. And so that means that you can lose a knight and the dragon is still going to be stopped by whatever 2 of the knights are still protecting the king. Hopefully that makes sense with the different RAID levels. And just briefly, I want to talk about there are some hybrid levels as well. So RAID 0 could be RAID 01, where you have like 4 drives. And what happens here is you have a stripe of mirrors. Your drives are mirrored and then striped across the mirror, or RAID 10, which is a mirror of stripes, or vice versa. But basically 4 drives, and you're mirroring two of them and then striping those 2 mirrors, and vice versa. You're going to stripe them and then mirror those 2 stripes. With RAID 5, there's actually a RAID 6, which is cool, but it requires another drive. And then you can lose up to 2 drives and still have your data. There's 2 of those parity drives in place. Now, the downside is you lose lose 2 drives worth of storage on your full array, but it's awesome because you can lose more than 1 drive. Now, even if you don't follow along with my awesome dragons and knights kind of scenario, hopefully the RAID levels make sense. Now, my little mental trick to remember what it is, I look at the number after RAID and I say, how many disks can I lose? Because for years I would confuse RAID 0 and RAID 1. But here's the deal. With RAID 0, you can lose 0 drives, right? Because if you lose one, you lose your data. With RAID 1, you can lose 1 drive and you still have another drive. RAID 5, I guess you could lose 1 of 5. I don't know. It kind of falls apart. But RAID 0 and RAID 1 are the ones that I would always struggle with. So I think of that number as how many drives I could lose and still have my data. I hope this has been informative for you, and I'd like to thank you for viewing.